In this video, we're going to be installing this APC AP7911 Power Distribution Unit into the retro rack, where I rack up late 90s to mid 2000s networking and enterprise computer equipment. This early 2000s PDU runs on 208 volts rather than the standard 120 volts we have here in North American homes. So we're going to try our luck running it on some 240 volt service I have in the server room. We'll explore its various remote management options, such as the serial console and Web UI, and finally, we'll write some quick and dirty bash scripts to issue SNMP commands, allowing me to remotely fire up the RetroRack's network. You can remotely turn individual outlets on and off with the remote management features of this PDU. Let's get into it. This is an APC AP7911 PDU, or Power Distribution Unit. It's meant to be mounted in the rack full of enterprise networking equipment and servers to give you a consolidated place to plug everything into power. There are two types of PDUs, metered and switched. This one is switched, and you can usually tell when there are LEDs next to each individual receptacle, and those will be on or off whether or not the outlet has power. As opposed to a metered PDU, where the whole thing is either on or off, but you can measure its current draw, hence the metered in the name. There's a big problem with this one though, as you can see, based on its types of receptacles and this massive power cable coming off the back of it here. You're not just going to plug this into the wall, at least here in North America. If we take a look on the back, we can see it's rated for 208 volts AC, not what's coming out of my walls here in the house. And as I was just mentioning, we obviously have a physical form factor problem here. In a previous video, I had gone over this 240 versus 120 versus 208 problem the serious home labber might run into. And I picked up this buck boost transformer. Basically, it can take 240 volts in. I have 240 volt service in the server room and 208 out. Now this would have worked. This would have been fine. Some folks were skeptical, but this is the right transformer, and the plan was I was just going to mount that up. But in the meantime, I picked up this adapter cable to go from this connector over to the connector style I'm using on my 240 volt outlet over in the other room. And I'm happy to report it actually just works. And some astute viewers in that other video noticed it does claim 200 to 240 volt AC out, even though it claims it only wants 208 coming in. Now this thing is perfect for my needs. It has a serial interface you can control these outlets with. You can also access that over Telnet or SSH. It's got a web interface, and it also supports SNMP. Long story short, I can send this messages over the network with my own software, or just the command line, and configure these outlets. But I don't have 240 volts in here. I like to experiment in here before I'm messing with the other room. So we actually have to physically move this into the room with the 240 volts. I guess I'll tell you a little bit about these plugs. These are NEMA plugs. There are many different variants. This is an L630P. Maybe you can just barely see that there. The P stands for plug, meaning it needs to plug into something. Then on the other end, with my little adapter, we've got an L630R, meaning it is a receptacle. It accepts a plug, and most importantly, it can support up to 250 volts. Actually, the current rating is probably what you really got to worry about, but we'll talk about that later. I'm going to hook this up and show you what's going on. Then over here in the server room, we've got the PDU plugged in with the Pro setup. This is how they do it in the data centers, guys. This is a 240 volt outlet, and I can't really remember why I decided to use this style of receptacle. I think I'd already bought this cable for the machine I needed or something. I'll probably swap that out for something else, something a little more standard data center wise later. Oh, and by install, I mean, obviously a certified bonded electrician came in here and did this, fully permitted. But as you can see, it's powered up. It's not complaining about the 240 volts coming in. Remember, this is theoretically a 208 volt rated unit. I was a little nervous about that, but it seems to be fine. Doesn't get hot or anything. Seems to be working okay. And let me tell you, when it boots up, it takes a few moments, and then every single outlet turns on, and there's an individual relay that click all at the same time, and it sounds exactly like a tantalum capacitor blowing, which really scares you. But yeah, it's doing just fine. We're going to interact with it over the serial console. I'll show you that. We'll interact with it over the Web UI. Let's start. I'll hook up the serial console, show you that. For some reason, APC decided to not use an RJ45 jack for their serial port. That's the serial port, and there's the network port up there. Of course, that's an RJ45. Typically with enterprise equipment, both network and servers, you'd have like an RJ45 to serial adapter or USB. This is commonly called a Cisco cable because the Cisco gear almost exclusively uses this type of serial connection. But just to simplify things, I bought a USB to this one. I don't know what that is actually. There are 6 pins in there. So let's get him plugged in. And this is my main home lab rack along with my home network. And so down here I've got this Dell R720. This is a Proxmox server. Easy access to it. So we'll get it in one of the USB ports right there. And while we're in here, we'll set up the network access as well. This is theoretically a 10 100 megabit port, and it won't auto-negotiate to the 100 megabit modern ubiquity switch down there for whatever reason. So whenever I have that problem and I just can't connect, I like to pull out Old Faithful here. We'll Linksys switch, so we'll get him powered on, and of course we'll plug it in to the PDU there, and then we'll get the other end of that going into my home network. This is a 192.168.1 network. Pretty mundane setup here. Aside from the hardware, obviously it's a rather impressive hardware array, but pretty boring network in terms of the network itself. Before we go mess with that thing remotely, let me sell you the dream here. So this other rack is the retro rack. I like to put late 90s to about mid 2000s networking gear, and then there's some servers at the bottom. The current power situation is abysmal. This is a PDU with manual switches, which I do like. We'll flip some of those in a second. 120 volts, which is fine, but it literally is plugged into another outlet that's like going under the door with an extension cord. It's a complete joke. I want to be able to remotely, with that PDU I was just showing you, with one press of a button, flip on the whole network, and then individually power on servers and sort of more exotic networking gear that I don't usually use. Now, it is very satisfying to come in here and kind of like flip these switches and watch all this stuff come to life, as you can see. So I'm kind of gonna miss that, but I want to be able to do that remotely. I don't leave this stuff running for 2 reasons. One is power consumption. They're old, they're hungry. I don't need that. My bill's bad enough with the modern rack. You saw those old Dell servers. And then I kind of just don't trust it. I don't want to, leave for a couple days and have all this stuff running. This stuff's pretty old. It's very reliable, but I only want it on when I'm messing with it, and I want to be able to turn it on remotely and easily. And by remotely, I mean 10 feet the other direction in the workshop there. So what we're going to do is go look at that PDU. I'll show you all its features, and then we're going to mount it on the back, I think. Here's a retro rack angle you don't get very often. So here's all the networking gear, and then the servers kind of start here and go down. I'm going to mount the thing over here so that I can bring all the power into it there. And after that, there's a lot more work to do. I need to fabricate like a panel for this. I still want some sort of physical switch I can press to turn at least the network on in here. The problem is, once properly configured and I've remotely turned some of these off, there's no way physically on the machine, there's no buttons. You have to interact with it remotely, and I'd like to be able to turn stuff on in here and in the other room. Over here in the workshop, I'm going to repurpose some of these amazing looking Liebert System 3 panels. In the previous video, I got this excellent chunky on-off switch interacting with an ESP8226 microcontroller, turning an LED on and off as a proof of concept anyway. Okay, so picture this. I come downstairs, I'm ready to do some retro computing. Bam! I get an LED telling me that my network is being powered. I got an alarm saying I can't reach the network yet. You can imagine that goes away after all the stuff boots up. That is the future. These microcontrollers are really cool. I've got a bunch of them. They're like dirt cheap. They've got Wi-Fi antennas, or most models. I've got a bunch of the ESP8266s, which are kind of old now. I think they're about to technically be deprecated. I think these days you'd want to buy the proper ESP32, but it's going to work perfectly for my needs. This is the one I'm prototyping with on the breadboard. You can hook screens up to them. I can't remember what I was doing with these, but you can get them doing all sorts of stuff. This TT Go one is really cool, and I think I actually have this one connecting to my Wi-Fi network just to prove it to you. So let's plug this bad boy in. Yeah, connecting to Wi-Fi. I think it's going to connect to my home network. Yeah, and then it says, "Hello, Alyssa." I was trying to impress my wife. She thought it was pretty cool. I'm going to teach this panel, when I press on with one of these, to power up all the networking gear, and I'll repurpose these LEDs to tell me, if something's not working, or something's off, or the panel can't talk to whatever. I'll go over the architecture I have in mind for the whole setup later. And then these are super cool. So I think I'm going to set one of these up in the rack, you know, just sitting there. It's got two little buttons, so I could like build a menu, you know, one that fires up the network, press a button, turn the network on or off, and then go through the server list, turn them on and off in there. I think that's going to be pretty sweet. But let's take a look at that PDU we just set up. We're going to start with the serial port. It's plugged into the serial to USB converter on that Dell R720 in my main home lab rack. And here I am SSH'd into that server. We're going to fire up a program called Minicom, which is a terminal emulator that lets you interact with serial devices. It's very, very useful. I would highly recommend you learn how to use it. If you give it -S, you're going to get this menu to configure it, and we can take a look at serial port setup. I already have this set up. You can choose the serial device. In our case, I happen to know it's TTY USB 0, that USB to serial cable I just plugged in. And from there, we can exit the configuration, and we're just sitting here in Minicom, and we're going to press enter a couple times. That's how these APC units work. And it's asking for a username. The seller, I bought this from eBay, already factory reset it. That's a pretty easy procedure, actually. So we're going to do APC, and the password is just APC, which is pretty nice. And here we are at the serial interface. It's been minutes for you, but I actually plugged that in with you together an hour and 7 minutes ago, the magic of cinema. And we can manage the device, so I can go into Device Manager, and we can look at Outlet Control Configuration. Here are all the outlets. They're all on right now. Trust me when I say that I could turn them off from here if I wanted, so let's go back and I'll show you what I did to kind of get this set up. So if we go to Network and TCP IP, this had been reset and was trying to do DHCP, and it didn't work. It wanted like a DHCP cookie set on the DHCP server or something like that. I didn't want to deal with that. So I statically assigned it an IP on my home network. It is at 192.168.122, and that's how we can interact with it. And so you can look at also, you basically configure anything you want in here. Look at the web interface. We've turned off SSL because this thing is from like 2003 or something. In fact, I wonder if we can find out exactly when this thing was built. Let's look at System, About System. 2004, okay. June 18th, 2004. 21 years old. And still works, gotta love that. It's giving me more module information. It's got the network management card installed on it. I don't think you can take that out, but they're probably using some sort of modular architecture behind the scenes. So what we're going to do is log out and Control AX to leave Minicom. I think it uses Emacs key bindings, which is really gross. There's a way better way to interact with things. But we can also telnet to this thing. It's asking for the username. And here I am. I could turn on SSH, and it's going to use some ancient SSH, security verification, and you could get it working that way as well. Let's log out, and let's fire up a Windows XP VM, and I'll show you the remote management interface, 2004 style. Here we are on a Windows XP VM, which is actually hosted on that same Dell R720 hosting Proxmox that the serial USB connector is plugged into. I love these Dell servers. If I had like infinite access to free electricity, I would just run racks and racks, hundreds of them. They wouldn't even be doing anything. They're just so good. But that's enough. I'm going to ping this thing, and we can get a reply. I have tried this before. In fact, I kind of poked around in a Patreon video, and a lot of the times the Patreon videos turn into real videos. So if you like that, go check that out. But IE didn't work, so we're going to try. What is this? I always forget. This is Firefox 3, Old Faithful here. And we are going to hit that same IP. You can see I've already done it before. And of course, it wants us to log in. And here it is in all its glory. It's beautiful. So it tells you the current load, the load on each bank. There's 2 banks. There's actually 2 physical breakers on the thing, and it's separated into 2 banks. Now what I'm going to do is go point the camera at that thing, and we'll remotely power off and power on some of these outlets. Got the camera pointed at the PDU, and we can go over here to outlets. Oh, it logs you out after 3 minutes of inactivity, I believe. Yeah, we're back in. So let's take the first, 3 of them. Click those, and I can say off immediate, next, apply, and they're off. And then I think I can say all outlets on immediate. Next, apply, and now they're back on. So that's pretty spicy, but I want to take those little microcontrollers and do that remotely. I think technically I could probably hack that together with this thing, but there's a better way. This thing also supports something called SNMP. SNMP stands for Simple Network Management Protocol. And I think in some ways it's simple, and in some ways it's not for the layman like me. What you're seeing here is I've installed the SNMP tools on my Ubuntu VM that's running on my, what is it, Windows? What do they even call it these days? It is still WSL, Windows Subsystem for Linux, but I think literally Windows is just running an Ubuntu VM behind the scenes. But at any rate, I've installed the SNMP tools and I can retrieve information about the PDU, or I can set configuration for it. This is very typical in all sorts of networking gear, Cisco networking gear, all sorts of networking appliances, servers, and all that. So what I'm doing here is I'm saying SNMP get, I want to get some information from it. Don't worry about that stuff. That's the IP of the thing. And then this big thing is something called an MIB, basically a directory structure. And they use integers separated by dots for whatever reason. And this whole thing together is something called the OID, or Object Identifier, for port 1, outlet 1. This is not going to be an SNMP video. I will set that up for the retro rack. You usually set up like a whole server. What I'm doing here is with SNMP clients, I'm just sort of one-off interacting with the PDU, that APC unit over there. And so we're going to get the status of outlet 1. And it shoots back integer 1. And after a lot of research, this means that it is on. So I can also get the status of outlet 2. It's also on. Now, the corollary to SNMP get is SNMP set. I can tell the thing what to do with this protocol. So this long command is saying turn outlet 1 off. In the case of this APC unit, setting that thing, it's like a hierarchy, like an object hierarchy. Maybe you can imagine that. I'm not explaining this very well. Set it off. And if we start over and ask for the status of outlet 1, remember that's what this long ridiculous thing is, it is now integer 2. So let's set the camera up again and we'll play with some outlets. And I think you'll see where I'm going with this. I can write software to run these commands. The camera is set back up, and as I just showed you, or walked through verbally with you anyway, outlet 1 is off. Let's turn it back on. Now it's on. And we can also turn off the other ones. Let's turn off number 4. I think you get the idea. This can be automated. This is very powerful. This is totally insecure. I'm using a very old version of SNMP, but it's going to be internal to my own network. It's easy. I don't really care. Now that we can interact with this thing remotely, the next order of business is to get it in the retro rack, racked up in the back, like I was showing you earlier. But you'll recall it's got some pretty funny looking receptacles on it. And that isn't anything that $70 US couldn't solve. These will literally give you cancer, by the way. Let me get these unwrapped. Now, I think most of us are used to this style connector. This is called a C13 to the typical plug. Its name escapes me. Anyway, as you saw on the front, I can't just plug this one in. I need a C13 to what's called a C14, which is literally the inverse of the C13. They can plug into each other like that. Now, I'm not sure why they do that for these enterprise PDUs. I'm curious to know. Comment down below why they do that. Maybe it's to prevent jokers like me from using, you can see we've got a gauge difference there from using the cheapest cable I can find. Actually, I'm thinking about this a little more. If you always had the receptacle for this on your device, you'd have to make different ones for different regions. This is like a North American and Japanese plug, maybe a few other places. But if you just standardize on something like this, anyone can get whatever kind of cable they need. I think that makes sense. I was able to buy 10 of these 6-foot C13 to C14s for 55 bucks, shipped to my house. But I bought this one first. I had dreams of having the very nice looking red cable for everything, but it turns out these are $10. So they are twice as much. Now, it's not totally apples to apples. This can do 15 amps. You can see it's literally thicker gauge, and this can only do 10. But that networking gear on the front can only pull, I think the highest current draw is the one that does a bunch of PoE. It can draw theoretically like 3 or 4 amps max. These are 10 amp cables. The important part for me is that they're rated for 240 volts. That's actually pretty typical. A lot of the time, even these cheapo ones are going to be rated for 240 volts, but you know, do your research. You don't want to be, you got to be careful with this stuff, especially if you're going to leave it running for more than 10 minutes. This is a 15 amp cable. I don't have anything, not even the biggest servers I have there at the bottom that would ever draw. If they're drawing 15 amps, you won't be seeing another video from me. I'll use this if I really need more than 10 amps. Hopefully I do someday, that'd be fun. The 15 amp thing, at least with regards to this PDU, is kind of a moot point anyway, because each bank can only handle 12 amps, and one outlet, its max is 12 amps as well. With the cables out of the way, let's talk about how you actually put this stuff in the rack. So you use cage nuts, cage bolts, I don't know what these are called, spacers, cage washers. Anyway, you put a bolt through the washer. This literally just protects your equipment from getting scuffed up as you plug it in, screw it in, I should say. This fits in the rack, and then of course you screw it in to the cage nut. Now, a lot of people hate the traditional cage nuts, cage bolts, probably because they were in a data center in 2002 and they had to rack up, you know, 300 Sunfire whatevers, and their fingers have never been the same since. I'm not in that situation. I'm going for period correct over in the retro rack, so I like to use the traditional cage nuts and cage bolts, but I do have some of these rack studs. The folks at Rack Studs actually sent this to me, not sponsored or anything. They sent me an email and were like, I got another pack too, and they were like, hey, check these out. I think you'd like them. The next time I have to mess with my home lab rack, I will use these, but I'm trying to say period correct, and a bunch of these, I bought like this huge bag of all this stuff on eBay, and a bunch of these like don't fit in the, that was a bad example. A bunch of these like don't fit in the spacer or whatever. And so I re-upped, got the fresh pack. So let's see here. Oh yeah, we got more spacers. I don't know what these are called. They're obviously called washers. Just like any washer you'd put on a regular bolt. I don't know why I was getting so excited about that. More bolts. And there are the cage nuts. So let's go rack that thing up. Here's the status update. I racked it up here. I think I said I initially was going to kind of put it on top of this server, but I decided pulling it up made a little more sense. I can't really get the camera back in there, but I'll show you a picture from the back. There's 5 networking appliances, and I've kind of got them loomed up into one power bundle. And then the main power cord, I also have some zip ties and some wire loom where I zip tied it to sort of protect that cable, because there's a lot of weight hanging off that cable, and it would put quite a bit of strain on this connector here. These racks come with these little wire ear guides you can screw in. So I've got one of those here, continued the bundle out, and at this point I realized I didn't know which wire was which, so I traced them all back and I labeled them. I've got 2 going up here for these 2 appliances, and then I'm going to loom this stuff up to use some of the excess for these 3 guys, these switches. So I'm going to do that real quick and I'll bring you back. I'm going to say that came out pretty good. So I loomed it up here and I was showing you the 2 branch off for these. And then I've got zip ties holding the Velcro strips for strain release here and wire control. Only the Velcro is touching the metal, so we won't get any rubbing on the wires or anything like that. 3 of them go down, and then we had just enough slack to go here, here, and here. And all of this is suspended and not under any strain, so the server can move freely. Very nice. I'm gonna get this hooked back up to the network, and let's write a quick little script that's going to fire all this stuff on, hopefully. That'll be sweet. I had completely forgotten that I left all those outlets on, so when I plugged it in, everything of course came to life and powered up right away. And guess how much current all 5 network appliances draw? A whopping 1 amp. So we are over provisioned. Back over here, I've written a couple bash scripts, one called off, one called on. Let's take a look at on. And it's pretty simple. This bash script is just going to issue commands, CLI commands in sequence for me. And so let's take a look at line 3. It's going to echo I'm powering on outlet 1 and the name of the device. And then the next line is that SNMP set, so it's telling outlet 1 to turn on, and then I have it sleeping for a second, and then on and on and on. Now this could, of course, be improved. I could have variables and have one script that does on and one script that does off. So for example, if we look at off, it's basically a copy, except it's turning everything off and saying that. So we will improve this in the future, but we're just going for good enough right now. So I'm going to set up the camera again, and we're going to run on, and hopefully we see everything coming on in sequence. All right, moment of truth. I got you pointed at the rack here. We're going to run on, and it should be powering everything on in sequence. I can't see the video, but I'm hoping that there are some lights showing up. The network will take a little while to come to life. So if I tried to ping that router, we're not going to get anything. So we'll take a few moments here. Yeah, not reachable. Oh, the router is up. So we'll give it a few more moments, and we'll see if we can interact with the network properly. Poking around, and I think everything's up. So the very top unit is a terminal server. It allows me to have remote serial access to each machine physically over the network. So we're going to telnet to that. And here we are at the Collab Retro Enterprises terminal server. And we can get into the HQ router just like that. And here we are. And I can do Control-Shift-6X to get out. And that is perfect. Now, let's try turning everything off. So no surprise, we're going to run off.sh. Got you pointed at the rack again. And I can hear the fans turning off. The aggregation switch is quite loud. Yes, this is very exciting. I'm overly excited about this. I've also critically updated my little retro rack inventory spreadsheet here, so I keep track of the static IPs of all the network appliances and the servers, their host names, the terminal server port they're on, and now the PDU port they're plugged into. The retro rack is growing up. But you finish one project and it just spawns more. This is the network situation. It's just sitting on top of the rack here, so that the PDU has access to my home network where I can actually interact with it while the retro rack is off. And over here we've got my new and improved power situation, along with what was already a pretty bad situation. But that's okay. Baby steps. We made a lot of progress today. Eventually we're going to get these panels interacting with the PDU, along with probably a couple of these little small guys. Have those around, and the plan is we're going to have the MQTT message bus in the middle of the architecture here, and I'll have a Go service which can interact with the PDU over SNMP, get information about it, set information, set the outlets like we did with the bash script. The Go service is going to be publishing status information about the state of the outlets and the network onto the pub sub, and the little panels can be listening for that, and they can also send messages into the pub sub and say, hey, turn on this outlet or do this action, and the little Go service will listen to those messages and interact with the PDU over SNMP and potentially someday even manipulate the network. The sky's the limit once we have this basic architecture down. So plenty of plans for future videos. Won't be using those bash scripts forever. Famous last words. So I'll bring you along as we write the software for that architecture, get these panels working, and we'll get some more power distribution in there as well. In fact, I recently picked up this little guy. My buddy Andy donated this APC Master Switch Plus, obviously a much older APC PDU, and it also allows for switching the outlets on and off, so we'll use that for other gear in the future. I am really liking what I'm looking at here. The line art of all the components on the top, just that attention to detail, that design, the aesthetic, like giving a crap about the thing you're making. We need more of that in the world. On the front, it's got a web management card and it claims SNMP. She's a smart slot. On the right side, it's got this thing called Advanced Port. I've been trying to break into this thing for a couple hours, and theoretically you can get, over the serial console, control the thing. This does not work for some reason. This says 2 UPS, so you'd put this into a battery backup system, which can talk to this thing, because each of its 8 power ports have an associated serial connection. And I think the idea is when the battery backup kicks on, you can tell computers plugged into these running some APC software, or maybe it's standard, I'm not sure, to shut themselves down, which is pretty sweet. It'd be fun to play with. And then on the back, you've got the 820 volt outlets. I'd like to incorporate this into the retro rack. It is reasonably retro indeed, but I need to figure out how to break into it. I've spent a couple hours on it, can't figure it out. I will bring you along for that in a future video. In fact, he passed a lot of other interesting stuff my way that you'll see in future videos someday. And yes, that PowerPC G3 Molar does indeed have one of the personality cards installed. But that'll do it for this one. I'm going to be at VCF Midwest in a couple weeks now, September 13th. It's a Saturday, 2025. So if you see me there, definitely say hi. I'll be roaming around all day. As always, thank you so much for watching. Please subscribe if you haven't already, and I'll catch you in future videos.